So I'm here to talk about a very generic topic about why we should be moving to the cloud and why not, and how people actually do that. So let's just crack on. So there's a bit of a safe harbor statement over here. Firstly, we're going to talk about some technical stuff. If you go ahead and do all those and it doesn't work, don't try and sue me. So keep that in mind. And I'm not representing Dell or any of the organizations that I've worked for in the past. This is just from my personal experience and stuff that I've read up and I've been working on over the last few years. So what are we going to talk about? We're going to talk about not why we should be moving to the cloud. I want to talk about why shouldn't we. I think we should. Well, depending on the use cases. Talk about some specific use cases, look at a few case studies, and then let's talk about how to get there. So why not? Let's look at each of these in a little bit of detail. So first of all, it's very easy to get to the cloud now, right? So not 5 years ago, 4 years ago, it was a bit tricky, and people were still not very clear about what this cloud thing is, and a lot of confusion around it. But I think we kind of gone past that time. We pretty much know what it is. Not pretty much, we all know what it is, and it's so easy to get to. I mean, there's like free tiers. I mean, you sign up to any of the cloud major providers, you get like 14 days, or in some cases 1 year of free usage on certain levels of compute engines. So yeah, it's easy. Documentation is clear and comprehensive. You can't believe how good it is. I mean, you can actually spin up a very complex, infrastructure in a matter of minutes just by going through documentation yourself. But obviously, that depends on your level of skills. If you are like a manager, then it's a good time for you, because there are lots of people out there now. I mean, not 5 years ago, it was very tricky to find cloud and big data experts. Now they're out there, the companies out there. Speak to Gravitas, and free consulting for you there, free marketing. But there are so many people out there, and they're available now. Let's look at the main aspects of architecture: scalability, availability, and performance. Cloud gives you all of those, not automatically, but you have to work for it, but it gives you. Nothing gives you scalability, availability, and performance better than what the new cloud systems do. On top of that, it also gives you automation. Let's start thinking about outsourcing. Look, we've been outsourcing for the last, God, I don't know for how many years. We've been outsourcing people. We put it to we're now doing nearshoring, right? Not only outsourcing, we're nearshoring, and we handing over project work for other people to do it. So let's try and get a look at things in a different way. Why don't we outsource infrastructure? And that is what cloud is. Infrastructure is often complex, and there is no reason for you to focus too much on it when you have people whose job, day and night job, is to work on infrastructure. For example, I don't know, you have a small website, you're an SME, you sell, I don't know, tickets to the opera. Why do you need to really focus on the Linux code? Why do you need to really think about network bandwidth? You don't really. Leave it to the specialist. Go to the one of the cloud vendors, and they will do it for you. You focus on your code, how to get more customers. So that's one of the areas. One of the other things people talk about, security. Oh, we shouldn't go to the cloud because it's not secure. Really? Think. Some of these, they're multi-billion-pound companies. Amazon, Microsoft. They wouldn't be doing business if their solutions were not secure. That's one thing to think of. But security is your responsibility, not their responsibility. Just because you put something to the cloud doesn't mean it's secure. It's just like your on-premises system. You tie down, you put firewall around your infrastructure, You put policies, you put all of those, you have to treat cloud exactly in the same way. So yeah, cloud is secure if you treat it securely. Look at the finance aspect of it. First of all, it allows you to bring cash in to your business faster, obviously depending on what business you're in. Your time to market is incredibly fast. Let's talk about, let's give you an example. You want to spin off a Cassandra cluster to build a search system for your customer database, right? In order for you to do that, Cassandra needs to run on bare metal, not on a SAN. So in your corporate IT, you have a SAN. But so you need to, I don't know, you want to make a 5-node Cassandra cluster, you need to provision 5 servers, get a code from, I don't know, Dell, and take you 1 month for the service to arrive. Then you get your engineers involved to set it up, do the network switching, all that stuff. So it's ready. Another 2 months, train your guys up. Seriously, that's 3 months, 4 months down the line, you have a cluster ready. Really go to Cassandra, find out there are AMIs available. For example, DataStax, one of the biggest suppliers of Cassandra, commercial suppliers, has got AMIs available. Within 5 minutes, you can kick off one of very, very fast, highly performant cluster in about less than 5 minutes. Seriously, something that you're looking at doing in 3-4 months, you can actually do it in 5-6 minutes. Obviously, on top of that, you have to secure it. You have to do. It's just not done like that. But I'm saying there are a few aspects of it. You can actually catalyze it. It gets high speed. The other thing I have noticed in my career that somehow I'm not a finance guy. I don't know much about finances. CFOs like to look at OPEX better than large one-off costs. For example, you have to provision infrastructure rather than spending, I don't know, hundreds of thousands of pounds to start off on day one. They would rather spend a little bit every month. I think CFOs like that, and you want to be in your CFO's good sides to do that. And then throughout the presentation, we will explore a few other things, which is if you are not using the cloud, you are not competitive. Let's explore that. So I think clouds gives you a competitive advantage. If your competitor is in the cloud and you are still on the data center, you need to think about it. So why not was the first question. Why shouldn't we be in the cloud? There are a few reasons that we could think about, or I could think about, that we don't need to. You may have a policy where your data cannot be, well, in multiple geographic countries, that may be a policy due to legislation, that, right? You don't want to be in a vendor lockdown. You don't want to put all your stuff in Amazon, and maybe you got something that you need to run multiple vendor platform, right? So you need to think about areas like that. You may be a government. You may be, again, that's down to a policy that you don't want to put your code. So UK government, you don't want to put in US soil, right? So that's again policy. The other reason could be people. You may have a CTO there, and he just doesn't like the cloud for whatever reason it might be, and you just can't get there. Then the other most important reason is you don't need to. You have a SME business where you don't need to. You're doing perfectly well, and you have your capacity. Whatever you are doing, you just don't need to. Apart from those few reasons I pointed on the right, I don't see why one shouldn't move to the cloud in today's day and age. Looking at the next slide, so let's look what cloud gives us. I put down some of the components, right? So today, as we look at the cloud, the number of components available is amazing. It doesn't matter what sort of business you are in. Amount of off-the-shelf products or components for coming from each of the vendors is amazing. They got everything you can think of. Like, you want to bring in data from multiple platforms, put it into the database, put in an analytics machine. They have components for every stage of it. So if you split this into, like, for example, on the left over here, I got Google's breakdown of their components. They have the compute engines, that's the VMs over there, the different services, the API services, different database layers, the different storage layers, load balancing, networking, big data, same. This on the right, you got Amazon's, you got Microsoft's Azure platform. Again, it's pretty much out there. I put an extra page for Amazon because I found Amazon to be slightly more comprehensive than the other two, because they have a little bit more in terms of individual components, like messaging protocol, like VPN gateways, like policies, like big data engines, is all there. And again, any IT infrastructure you build, you really have few stages of it, like your application tier, your data tier, and the network tier that combines you and your clients and your machines together, and how you deploy your technology, your stack, your code there. So you see, these are the layers, and they have so many variations of it. We're gonna dig a little bit more into each of these, but let's look at a few of the use cases, right? So let's look at use cases of why one should use the cloud. So it doesn't matter what business you're in, you're going to kind of fall somewhere between, well, I'm hoping you'd fall in somewhere in one of those. You have a web application, you are in a web application hosting business. By the way, each of these links take you to these are actually taken from Amazon's architecture page. So you can actually look at the detailed diagram of how to build. They are best practices PDFs. So you can actually follow those PDFs and build a very nice web application hosting platform very easily. You may be in a content and media serving business. Online games, very famous. Right? They're using cloud. Ad serving, very popular, very revenue intensive. They're using media sharing. Very powerful. They're using lots of companies in that business are using the cloud. DR, a very hot topic. It's a very nice place to put your DR systems, right? So if your something happens, your existing data center infrastructure goes, you can shoot off your infrastructure in a matter of seconds in the cloud. The other option is you could, for example, if you're already in the cloud, you can run a live DR environment. So you can actually build a fault-tolerant, highly available system that's actively DR at the same time as being serving your customers. One of the most exciting areas of cloud for me is big data. And areas where you couldn't do it before, or you could do it, but it would take enormous amount of time to procure, recruit people, to even build infrastructure to do large volumes of any of these. Log analysis, right? So, lots of log analysis need to be done in various industries. Security logs, in your machine logs, understanding your customer behavior. Say you have a website which is getting some sort of revenue every month, but you see a lot of customers who actually go and browse but don't buy it. So you want to analyze it, every behavior. You want to bring down, so you're getting, say, 1 million hits a minute. To build an analysis environment for that, to build infrastructure on your own rather than using the cloud, is going to take you months. So you can leverage the cloud for things like those. Large-scale processing of huge data sets. Let's take a Large Hadron Collider. It produces some crazy amounts of data every second. So to analyze things like those, you need the cloud. Financial grid computing, time series calculations. Obviously, you need cloud is one of the best ways of doing those quite fast. My favorite one of my favorites of using the cloud is, don't tell me, show me, is POC. Rather than talking about something, go and build it. It's so quick and easy to do it. You know, you got a board level presentation to do. You want to sell something. You want your organization to invest on it. You know, it's going to go on for months. People go, how are you going to do it? How is it possible? Actually, go and do it. The tools are out there. The components are out there. Build it yourself and then present it. Say that you can do it. This is a small pilot. You know, this is how you do it, and then present it. I've used that in my career many times, and with great results, successful results. Another favorite is test systems and continuous integration. You know, it doesn't matter what development environment you have, you can pretty much get them going in the cloud pretty easily. And I'm going to go to the next slide. So again, this is a very Amazon AWS specific one, but that's because I know more about this AWS than other platforms. All, even Microsoft, Google have a very equivalent things like this. So it doesn't matter what language your developers write code in, how you deploy applications. There are plugins, there are add-ons, there are environments made available by that cloud vendor for developers for that stack, and it's pretty easy to get to. All right, so running into case studies. It's best I take questions later, but I'll run through this because we've got a time pressure from Ross, 20 minutes. So over here I listed some of the interesting use cases from Rackspace, right? Not use cases, case studies. Aussie agency, a car manufacturer. I don't think you can read it over here. I can hardly read from here. A Mexican book. So I just want to show the different industries they're using the cloud, and they're using it fully. The next is Microsoft Azure platform. GE uses it. Is interesting read. It's worth going to those pages, the case studies, and it's actually an interesting read. Not all of them use it fully. Some of them use part of their application stack. AccuWeather, to accurately measure weather or predict weather movements on those, they use it. Glasgow City Council uses it. EasyJet uses it. We all know them. This is Google. Best Buy uses it. Coca-Cola uses it. DB Shards uses it. London Heathrow uses it. Met Offices uses it. And some of the other interesting ones over here from Amazon again is Channel 4, Chef. If you guys are in DevOps, you have used Chef. They use it. Expedia uses this, and Netflix. Netflix is particularly interesting, and I actually follow their blog very closely, and they are one of the exciting technology companies. In addition, I actually never watched Netflix myself, but I love their blogs. The technology they use is cutting edge. Apparently, I read somewhere, and obviously don't quote me somewhere, because apparently at times half of the internet traffic comes from Netflix. So that level of bandwidth and communication, they are fully on AWS. Their big data, their analytics platform, which runs on PrestoDB and Hadoop backbone, uses AWS services. They use Cassandra. Everything out there is there on Netflix. It uses AWS. All right, let's look at the next slide. All right, so I think that's I've gone through why. Let's talk about how would you. This is a kind of sort of fictitious environment. I'm going to talk through how would one go to the cloud. So let's, on the top half is the cloud, and bottom half is the on-premises environment. Let's look at a simple company. Let's assume they have a website that runs from a MySQL engine, and they have a data warehouse platform built on Oracle. Ross, how am I doing for time?
Honestly, take as long as you want. But,
I think 3 more slides.
20 minutes, so
Okay.
yeah.
So say they have MySQL and they have Oracle. They ship some of the data using, say, Shume Technological Golden Gate, and they have Oracle Business Intelligence, and So these guys want to use the cloud, they want to expand. They obviously, MySQL doesn't scale, well, unless you put in lots of energy and MySQL Fabric and lots of other technologies to it, it doesn't scale as fast. So they want to be global, they want to do much more, they want to analyze data fast. So how would they do it, right? So say they started using Amazon, and they put in few things there. They put Amazon RDS and put a MySQL, and let's just assume they started doing some testing out there. And they make a grand plan after that, right? So in parallel to that MySQL engine, now say they put in some ETL engine, put the data through JSON, and let's assume they're thinking of replacing MySQL in MongoDB, yeah, because that represents the customers better. They want to build a search engine using Cassandra. So this is all happening in real time. Their existing application, their customers are still logging into MySQL, but on the side, in the cloud, everything is happening in parallel. They are building a test platform with real-time data in the cloud to see how everything works. And rather than using Oracle, they decided, for whatever reason, to use Amazon Redshift and see how well that performs. Then they use a messaging protocol, messaging system from Amazon called SQS to bring the data to Elasticsearch to see whether they can get good visualization from it. So that's what they built in. So they also want their existing customer base or whatever, their management to still use Oracle Business Intelligence. So they bridge a network, they put a VPN between the two and still bring the data across. So existing customers, what they're used to using, they still use, but in the background they started building this amazing, highly scalable technology using lots of open source technologies out there. So now they want to do further analysis to see where are they losing the customers. They want to dig deep into it. So they bring in Hadoop. They use Amazon's MapReduce, which is the EMR platform. They use Spark. They build cubes. And actually, again, bring them back to Oracle, because all their management actually likes the Oracle reports. So they bring it back to the Oracle layer. But now they do all of this in the cloud, right? Now, when everything is working, so the business intelligence works in cloud, and they have seen that their web application actually runs on MongoDB, they actually put a front end, the existing front end, make some rewiring and put it in MongoDB, right? And now they decided to decommission the old stack. So you see, by doing some steps and being a little bit of thinking out of the box, being a bit creative, and taking that, not leap of faith, but taking all this new technology that's available, they have managed to create a pretty amazing platform. In a matter of few months, they started off at 10% with a test environment, went to 60%, where they started putting all the new projects out there, and kind of by the end of maybe within a year, they're pretty much 100% in the cloud, and they have decommissioned all the old systems. So this is just an example of how you could do it. The other thing I wanted to go through in the last slide is some housekeeping. Just going to the cloud is great, but once you are there, you got some responsibility. With great power comes great responsibility. Spider-Man, hey? So security. Security is often an afterthought. No, you can't do that with nothing. Especially security is the key for everything, right? You don't want to put your intellectual property, all your assets in the cloud, and next day it get hacked. No, you wouldn't do that in a data center. Why would you do that in the cloud? So treat security from day one. Log everything. Most cloud vendors come with lots of logging tools. Every server that you launch comes with automated logging. So put logging in. Get your CISO team to work with your DevOps team closely. Put those policies in together. Availability, yes, cloud comes with a sort of promise of everything is fully available. It is true, but you have to do it. You have to wire all the pieces together and make sure there's no single point of failure, right? So it's your responsibility to do that. Costs, build in a cost management structure. So otherwise, it could be creeping. You know, developers love using the cloud. You need to put a policy in, like, which developers can put which machines, or do they need further requests? What works for your organization? Look into it. You can put a server that costs like £14 an hour, right? Put 500 of those, run it for a week. You probably busted your entire company's budget. So you need to think. You need to put a structure in who can do what. You know, what request goes to who. There are tools. There are lots of tools that helps you to manage cost in the cloud. Logly, I can think of. I think there are Cloudin. There are hundreds of those out there these days. And for example, with 1% of the cost, they charge probably 1% of your monthly cost, and you'll probably end up saving 8% of your unnecessary expenditure on the cloud, because they will actually track it and give you recommendations of what you should be running, where you're creeping costs and stuff. So that's the business case to use tools like those. I think I'm pretty much done. That's it, really. I think after this we got some specialized presentations from Jagdeep and Jack. But if you have any questions, I've already probably taken 50, like the cloud creep. I've obviously taken more time than I was allocated. But if you have questions, I'm happy to answer.
Would you recommend a hybrid model where you have the overflow into the cloud, but a base level of servers outside the cloud, because you know that they're going to be utilized?
It absolutely depends on what your business needs, but that's a totally acceptable model for many cases. But it depends if you need to do that. You may not need to do it. If you're happy to do that, move everything to the cloud, you could do it. But sometimes hybrid is the only option. So again, it totally depends on the use case, really. It comes with some extra cost, having a hybrid model. It gives you some extra flexibility, some extra cost, some extra housekeeping, some extra software licenses to consider and stuff. But, you know, it's worthwhile.
You may have already covered it, but for those of us who are less technically gifted, you mentioned the second slide about how the cloud and security is no different to having internal infrastructure. How and why do you think that those of us who are less technically gifted haven't quite cottoned onto that and do have this big fear about the cloud and security?
I think is the fear about using anything new, right? So it took us quite a long time to get into data centers, and you know, everyone having their own sort of subsection of their racks and securing it all down and stuff. So cloud, even though it's quite mature, but it's still new to lots of people. So it's just jumping to your new phone. And I got a work Nokia phone in my pocket, and I just don't use it because I'm so used to my iPhone. I rarely use it. So I think it's just that bad. That plus, you also have that uncertainty which has gone to lots of people's mind, that I don't know where my data is, and that sort of created that culture of skepticism, isn't it? So you don't really know so it's a scary place, but it isn't. That's all I'm trying to say. It isn't. It should start there.
There's an element there of as well of security is the one thing you kind of want to keep in-house, because when you start outsourcing security, you let go of control of your own security, you're losing something. It's like trusting somebody else to keep your PIN number secret for you. You know, you keep your PIN number secret because that's the whole point of having a PIN number, is that you control it. Once you hand something off to somebody else, you no longer have control of it. You're kind of putting that out into the open domain. Security is the last thing you're going to want to do that with.
Very important point. I think we should discuss this offline, but I don't necessarily agree with that, because if you look at some of the largest organizations in the world, they have actually outsourced the security in various tiers, right? They have developers sitting in India actually writing code for Bank of Scotland, for example. Yeah, so it's a small company out there actually writing, packet level encryption out there. So if you take that, so we are already doing it. But the concept is exactly, security is very paramount important to you, so you should definitely have control of it. But do we really have control? Is what I'm asking.
I'm not kind of that mindset, but I think that's where the reluctance to move into it.
Oh yeah, of course, of course.
It's not just, oh, this is new, we're kind of like cautious.
Yeah.
I think there is a kind of a common sense boundary that you need to persuade people past.
Yes, I think you're absolutely right. What I would say is, however, you can actually put in the security you want in the cloud. Just because you're using Amazon doesn't mean you have to use Amazon's given cloud security. You put in your Cisco or your whatever you want to, you can actually implement those. These cloud systems gives you flexibility to actually do what your CISO recommends to do that. But it takes time. It doesn't happen straight away. You may not have the exact same flavor of the firewall out there. You may have to do some compromises. Some of them probably a good compromise, not really compromise, but I agree, totally agree with you. That's probably one of the reasons for that reluctance.
Cool. Well, thank you very much, Pratim. In that case, we just grab 5-10 minutes, freshen up.